writing quadratic equations in vertex form. So why would we ever want to complete the square? That's generally the consensus when we learn completing the square, and especially in Algebra 2, when you already kind of know where completing the square leads. Why would we do it? Well, it really is probably the simplest way when you do it on the right kind. But really, one reason we really learn it is so that we can derive the quadratic formula. And you probably got that reason in Algebra 1. And that's important. We can talk more about what that means. But the other reason is so that we can easily put something into vertex form. And that's what this one is about. Because sometimes you don't care about the x-intercepts. Sometimes when you have a quadratic equation, what you really care about is the vertex. And yeah, you could find it by doing other things, but let's see how we can use completing the square to find vertex form. So we're going to do y equals x squared minus 18x plus 15. So you know that the y-intercept is 15, and you could find the axis of symmetry and you could plug it in. Now, but if a wasn't 1, you'd have to do some work to get the vertex, right? So this way, we're going to use completing the square to put it in vertex form. We're going to rewrite this part with, I'm just going to, instead of moving this to the other side of the equal sign, we're just going to move it off to the side. And we're going to, once again, come up with a new c and just add that to both sides. So same thing as completing the square. We're going to do b over 2 squared to get our new c. In this case, negative 18 over 2 squared, which is negative 9 squared, which is 81. So we're going to put 81 on both sides. 81 here and 81 here. So we've got 81 plus y equals, now that we have a perfect square trinomial, that factors really nicely, and you start to see why we call this a good way to put it into vertex form, because we're really close to vertex form. What's the only thing that makes us not in vertex form? That renegade 81 over there. So we're just going to subtract that 81, and we have y equals x minus 9 squared minus 66. And there we are in vertex form. So I could tell you what A is, I could tell you what H was, I could tell you what K is, but in any case, the vertex is 9, negative 66. So that was pretty painless to put that in vertex form, to come up with what the vertex is there. We've got y equals 3x squared plus 12x minus 10. And so we're heading for vertex form. I'm going to write this off to the side. Y equals a times x minus h squared plus k. Because here you can see one with an a, and we haven't had ones with an a that's not one for a while. I just want to remind you that there's never anything inside where I just made that pink, right? That's always just a plain old x. There's not a coefficient of x. So we've got to get this equation to where it doesn't have that number in front of the x or the x squared. So we're going to only factor the 3 out of the x squared and the 12x. So notice 3 times x squared is our 3x squared, 3 times 4x is our 12x. We're going to end up adding something there and adding something there, but I always forget this, so this is a good time to do it. I'm going to need the 3 over there, because when we fill in this blank, we're going to fill in this blank. And that 3 is multiplied times that new number, so we need that 3 to be multiplied by that new number over here. I always forget that step. So you need to come up with a time that you do it, and I always do it when I first write those parentheses. Those parentheses remind me if there's something out in front of them, I need to write something else in front of the other side. Okay, so we're going to get our new c, b over 2 squared, which is 4 over 2 squared, which is 2 squared, which is 4. So we're going to put a 4 here and we're going to put a 4 here. But now this makes it 12 plus y equals 3 times x plus 2 squared minus 10. All right, so the 12 came from the 3 times 4 on the left side. There you go. All right, so now we just have one step that was the same as the last time. We've got y equals 3 times x plus 2 squared minus 22. So my vertex is -2, -22. And my a is 3, which we didn't have an a before, but just to remind you that that's there. Step 1, if we have an a, we need to factor a out of ax squared and bx, and put it on the left side also. And you can put that on your own words. I don't really have a great way to say that. Right? Those 2 3's that are circled, we needed to factor it out, and we needed to put it on the other side. And at the same time, I'll put it as step 2, but step 2, which is really step 1 if we don't have an a, that's not 1, is move the c off to the right. That's where we started on our first example. After we moved our c off to the right, we get a new c. And add it to both sides. I would put a note there about to be multiplied by a on the left, right? Meaning we had that, put that 4 on both sides. It was in a position to be multiplied by the 3 we had already put there. Step 4, on the left we multiplied, on the right we factored. And that, again, on that left multiply, that's only if we had an a that wasn't 1. On the right, we'll always have to factor. Step 5, move. Let's not put move. Let's put add or subtract to get y alone. And that's it. That gets us into vertex form and made it very easy to write our vertex.